of an equation of a line. First of all, we are linear only. So the important piece about that is knowing that we are degree 1 across the board. There are no, that looks like a degree. Okay, now it looks kind of like a 1. We're degree 1 across the board. There shouldn't be anything squared, there shouldn't be anything cubed, there are no square roots, there are no fractions, there are no weird things like that. We are degree 1 anywhere and everywhere. So the way that I talk about standard form is that variables are on the left and constants are on the right. So variables go on the left, constants go on the right. When I say constant, I mean just the number. 5, 7, -12. So we're kind of doing this organizational piece where we want everybody with a variable on one side and everybody that doesn't have a variable on the other. So let's start off by looking at standard form. So some of the questions will say to rewrite in standard form. Is this in standard form as it says? No. What needs to move? So there's one thing that needs to move. What needs to move over? The what?
The y.
I could move the y over, but then I'd have to move something else. What do you think? Yeah, I heard the 3x. So the 3x is what I'm going to move. Remember when you're solving stuff and it has an equation is when there's an equal sign. When you have stuff and there's an equation, if you do something to one side, you have to do it to the other. So if I subtract 3x from the right side, I also have to subtract it from the left. So all your rules still apply to solving equations. Okay, so this cancels, set equal to 8. Now is it in standard form? Okay. So when is standard form a good thing? Typically, we like standard form if we're trying to find x and y intercepts. Do you remember to find an x-intercept, we plug in 0 for y? To find a y-intercept, we plug in 0 for x. This tends to be the best form, or the easiest one to calculate both the intercepts. So that's why we might like standard form. Okay? This is our answer, though. And boom, that one's done. Standard form isn't used a super lot, though. Like, it's a little bit, but it's not something we use a ton. So we use slope-intercept form way more. So slope-intercept form, y equals mx plus b. M stands for slope. Why they picked the letter M, I don't know. My favorite teacher in high school used to just joke about it because she was like, it sounds like slope, right guys? Slope? It's a bad joke, right? Math teachers have bad jokes. Again, same thing for y-intercept. Y is the letter B. Like, that doesn't make any sense to me either, but that's where we live. So remember that M does stand for your slope, even though M doesn't make any sense for our slope. And B stands for your y-intercept. Also remember that if you ever need to calculate your slope, it's this format. Okay, so if M equals, we've got y values being subtracted and x values being subtracted. Sometimes we say the change in y over the change in x. We call it different things, but that's your general calculation for slope if you have 2 points. Okay, we only have 3 more examples. Are you ready for some examples of slope-intercept? Woo, we're so excited. Okay, good. All right. So if we want to write it in the form y equals mx plus b, again, I need to know m and I need to know b. I've got to fill in for both those things. You're not going to fill in for x and y. X and y are going to live on in the equation. Those stay there. All right. B is my y-intercept. So look at your graph. Remember, this is my x-axis and this is my y-axis. What's my y-intercept? 3. So I'm going to plug in a 3 right there. And then I also want to figure out my slope. Remember that when you're looking at a graph itself, you can you can go through and use that formula, or you can even calculate rise over run. So I think I'm going to do rise over run here. In this case, we're not even rising because we're falling, right? So I'm going to go from this point to this point. So I fall 1, 2, 3, 4. So negative 4 would be my numerator, over 1, 2, 3, 4, 5. So negative 4/5 would be my slope because I dropped 4 and went to the right 5. Remember that you always read a graph like a book. So you're always going to read it from left to right. And I say that and then I think about my son who sometimes reads the anime books and those who actually read backwards. But we're going to assume not like an anime book. Alright, so y equals negative 4/5 x plus 3. Again, fill in for m, fill in for b. That's all you need to do. So sometimes you'll be given a graph. Sometimes you'll be given an equation and asked to switch it into slope-intercept form. So slope-intercept form means we want y all by itself. By the way, this is a typo. This should be an equals, not a plus sign. So switch out that plus sign for an equals. Okay. So now that we've done that, we want to isolate y. That's how we get into slope-intercept form. What might you want to do first to try to get y by itself? Yeah, let's move the 10x. So I've got negative 5y equals negative 10x plus 25. So the 25 is still positive, it just was sitting on the other side of the equal sign. Okay. Now, y is almost alone, but not quite. It still has a negative 5 with it. How can I remove the negative 5? Yeah, let's divide everything through by negative 5. Okay, and again, remember to divide everything. You can't pick and choose and like, oh, I'll divide you, but not you. Remember, it has to be everything because it's an equation. Negative 10 divided by negative 5 leaves me with what? 2. And it's positive, right? Because it was a negative divided by a negative. And then 25 divided by positive 5? Negative 5. And there's my equation. So my slope is 2. I'd be going up 2 over 1, up 2 over 1 if I was graphing, and my y-intercept would be at negative 5. Alright, we've got one more example, so flip to the back. This is probably the trickiest one that involves slope-intercept form. So there are a couple different types of problems. This will be the one that's a little bit trickier than the others. Alright, so we're going to stop here, just so you know. So we're going to deal with point slope tomorrow. Point slope gets its own day. Okay, for this one, we're given 2 points, and we want to calculate slope-intercept form. I didn't give you a ton of space, so we're going to have to make do with that. Alright, pick one of the points and call it x1, y1. It doesn't matter which one you pick for x1, y1. I'm going to use that one. And I recommend you use the same just so that we're consistent on this problem. But for everything else, you could be a rebel. And you could flip them, and you're still going to get the same answer. Okay? So the other one is going to be x2, y2. So again, it doesn't matter which point is which. What does matter is that the subscripts are these little baby numbers. It matters that those are the same. So you can't have an x1 and a y2. But they both have to be baby 1s, or they both have to be baby 2s. Okay? Alright, let's start by calculating slope. So remember y2 minus y1 over, oh, you can't see on your map. There we go. Over x2 minus x1. So I'm going to plug in. So I have 13 minus 5 over 3 minus 1. So 13 minus 5 gives me 8. 3 minus 1 gives me 2. So what's my slope? 4. Well, yeah, it'll end up being 4x, right, when we put it in. But just 4 by itself is the slope. Okay. So we've got the slope. Let me think about my equation for just a minute. So y equals 4x plus b. So I'm here. In order to find B, do you see how I have so many unknowns? Like I don't know Y, I don't know X, and I don't know B. Like that's a lot of problems. So what I need to do is pick one of the 2 points and plug it in, because then that can help me find B. I usually pick the smaller numbers because I want to make my life a little bit easier. So remember, this is Y, this is X, and do you see how if I plug in an X and a Y, I can now solve for B because I only have one thing I don't know. And if you wanted to, again, you could have plugged in this point. It doesn't matter, you'll get the same answer. Alright, 4 times 1 is 4, so 5 equals 4 plus B. How can I solve for B? Subtract 4. So B equals 1. So I know B is 1, I know M is 4, and just like we talked about with the last problem, that's all you need, right? M and B, that's it. So Y equals 4X plus 1. So again, find your slope, find your y-intercept. And once you do that, plug them both in. What do we think? Is it coming back? Again, that's another reason. Huh? I think so too. And again, that's why we call it, like, so in the biz, we call it spiraling, where stuff comes back again, right? And hopefully it's a little bit easier to understand as it comes back to us. All right, we are on assignment number 5. I will put my book under the .cam in just a minute. The homework is page 97, numbers 1 through 12. So not a ton of homework. I think today could definitely be a day that you like get it done, and then you're like, I don't have math homework tonight. That's my dream for you. If you are somebody who needed to finish up any old homework, today would be a good day to do that as well, because you've got a lot of class time, and I am here to help. So today would be a great day to finish up, especially stuff that you were concerned about and didn't understand. Also, remember that you have a quiz coming up on Friday. Okay, so I'm just going to keep reminding you of that as we go. All right, 97.